Welcome. This is the introductory PowerPoint presentation, just to quickly go through some definitions of what we're going to be coming across as we go through our study of astronomy. First of all, astronomy is the study of objects in the sky beyond the Earth's atmosphere. It's the study of the motion of the stars and planets. We also need to look at the instruments that we're going to be using to study astronomy, so telescopes jump to mind there. And we're also going to look a little bit about our historical development of our understanding of the universe. So let's start off with our definition of what the universe is. The universe is everything. It includes all matter, all space, and what is quite unusual and difficult to understand, it includes all time. So time started when the universe started, and that all started with the Big Bang 13.8 billion years ago. Since that time, we're getting a stronger understanding each day, especially with information from our experiments at the Large Hadron Collider. We're starting to get an idea of how that early universe formed and how it's progressed to what we have today. So we need to keep in mind that the universe is absolutely huge. Stars are very distant, and light from those stars can take thousands of years to get to us. So when we observe stars, especially when they're stars very distant to us, we're looking back in history. Okay, the Sun is a very important star to us. It enables life to continue on Earth. Our Sun is one of 100 billion odd stars that make up our galaxy, the Milky Way, and there are roughly 100 billion galaxies in the universe. So I know these numbers aren't that accurate, but they're easier to remember. So 100 billion stars make up the galaxy, and 100 billion galaxies make up the universe. Interestingly, on average, every star has about one planet. So if we know there's 100 billion galaxies with 100 billion stars, we know there's a similar number of planets out there as well. So this image here is of the Hubble Ultra Deep Field. This is a image that was taken on a previously thought of as a dark piece of sky. So the Hubble telescope was pointed towards a piece of the sky that was just seen as dark on telescopes. So they kept the shutter open, so they were collecting this image for about 20 days to capture as much light as possible, and lo and behold, that previously thought of as like a bit of sky that had nothing there, we have all of these dots, and a lot of these are galaxies. So as I said before, the galaxies, each one of these could contain up to 100 billion stars. So the more we look, the more we find. Just something else I would like to talk about is when we're looking at constellations, it's the naming of constellations. So we often group sets of stars in something we call a constellation. So here we have Centaurus, and there's a naming convention based on the brightness of the stars within that constellation. So for the constellation of Centaurus, which is inside this blue line, the brightest star that makes up that constellation is called the Alpha, so that would be named as Alpha Centauri. And the next brightest star happens to be next to the brightest star, so we would call that Beta. So we go Alpha, Beta, Gamma through the Greek alphabet, labelling from the brightest star